What if the secret to perfecting your machine learning model is understanding the concept of overfitting and how to avoid it? Imagine training a model so well it can predict every single detail of your training set, but when you introduce new data, the model fails drastically. This phenomenon is what we call overfitting. It's like memorizing every answer to every question in a textbook, but failing when faced with a real-world problem related to the same concept. Now, to combat this, we have a powerful tool in our arsenal known as regularization. Regularization, in essence, is the process of adding information to prevent overfitting. It introduces a cost term for bringing in more features with the objective of keeping the model simpler, thus less likely to overfit. Think of it as a balancing act. On one side, you have the need to minimize the loss function. That's our model striving to fit the data as perfectly as possible. On the other side, you have the regularization term, trying to keep the model simple and prevent it from learning too much from the noise in the data. The regularization process can be broken down into a few steps. First, you would select a type of regularization. Lasso and ridge are two popular methods, with lasso tending to eliminate unimportant features, while ridge reduces their impact without completely eliminating them. Secondly, you would determine the regularization parameter. This is the value that controls the impact of the regularization term on the loss function. A higher value increases the influence of the regularization term, thus increasing the simplicity of the model and reducing the risk of overfitting. Lastly, implement the regularization into your machine learning algorithm. This involves adding the regularization term to the loss function in your algorithm. In summary, overfitting is a common issue in machine learning where a model performs exceedingly well on the training data, but fails to generalize on unseen data. Regularization provides a solution by adding a penalty term to the loss function. This penalty discourages overfitting by either reducing the impact of less important features or eliminating them altogether. The balance between fitting the data and keeping the model simple is regulated by the regularization parameter. Remember, in data science, as in life, it's all about balance. Too much of anything, even learning, can lead to less desirable results. Regularization gives us the ability to find that sweet spot where the model is complex enough to learn meaningful patterns, but simple enough to generalize these patterns to unseen data. So next time you're faced with a model that's too eager to learn, you know how to gently guide it towards the path of generalization. Remember, the key to mastering machine learning is not just about training a model, but understanding how to optimize it. That's where regularization comes into play. It's not a silver bullet, but it's a vital tool in your machine learning toolkit.